my machine learning project, which focuses on recommending daily diet plans for diabetic patients. The idea is to use machine learning to help people manage, control, or reverse their diabetics through personalized nutrition. Um, we look into opportunity evaluation. So, is there a problem? Yes, diabetes is a major health issue globally, and the diet plays a huge role in managing it. Most patients don't have access to personalized meal plans, and even it's hard to stick to them. So, I believe machine learning can help with analyzing the health data and generate tailor-made health meal recommendations. And this matters not just to the patients, but also to the doctors, caregivers, insurers who are investing in better health outcomes. Let us look into the CRISP DM business understanding. We'll first define the problem. Using the CRISP DM framework, I started defining the problem. The target users are primarily the diabetic patients, type 2 diabetic patients. The issue is that they need meal plans that adapt to their health data and preferences. Right now, most solutions are either manual or generic apps, which don't offer much personalization. That is a gap that I'm trying to address. The success criteria for this project means improving health outcomes and helping patients stick to their diet plans. I'll be looking at metrics like changes in blood glucose levels, HbA1c scores, and how consistently users follow their recommendations. There will be certain constraints like data privacy, cultural food preferences, and availability of real-time health data. Coming to the identification of the factors, um, we'll need input from domain experts like dietitians and endocrinologists. I've identified several factors that could influence recommendations like age, weight, activity level, glucose readings, and dietary preferences. These will help the models personalize meal plans effectively. The solution validation plan. Um, I would like to recommend a solution, which is an engine that suggests daily meals based on the user profiles and the health data. I plan to validate it in three phases. The first phase is by testing a prototype with synthetic data and expert feedback. Second, by piloting it with real users. And third, by iterating based on feedback and performance metrics. Coming to the system design, I've made few key decisions. Coming to edge versus cloud, I'll use a cloud-based setup because it's easily scalable and easy to integrate with other systems or applications. Between offline and online learning, the learning will be offline because with periodic updates, things will be stable. And between batch-based and online predictions, I would recommend batch-based because once or twice a day is when users would want meal recommendations. So it doesn't need to be real time unless there's any major change in the health data. Coming to the risks in production, yeah, I've thought about few risks. One is training uh, data, where data used to train the model may not match with what we see in production. There's also a risk of data drift, like changes in the user behavior or dietary trends, and concept drift where the medical guidelines may evolve. To manage these, I might set up monitoring systems and retrain the model regularly based on feedback and new data. Um, to wrap up, I believe this project has real potential to improve diabetic care. By using machine learning to personalize meal plans, we can help patients make better dietary choices and improve their health outcomes. Thank you.